in the multiple choice. So I checked with 0 period. You guys can re-enter answers right now if you want to, right? So as we correct, you should correct if you're uncertain of anything that you did in there. So we're just going to correct these 6 slides, 3 quick, like multiple choice, just kind of do I understand how to pull out this number, and then 3 kind of longer, those conceptual ideas about what's really happening to the graph, okay? So I'm going to ask you guys to help out here. So the A value in this equation, who can explain to us what they pulled out as the A value and why? Go ahead, Connor. A 1, okay? Somebody want to tell us why he pulled out a 1? Okay, good. So it's not seen there, and we have to be careful with which operation it is, right? Good. If it was 0, it would be a horizontal line. So it's really important that we understand that that A value doesn't appear to be in our equation, but because it's multiplying the absolute value, it would be the multiplicative identity, which is like having a 1 there, right? So 1 was our A value in this equation. All right, what about our H value? Who could give us that response? Ethan? Okay, so H is tricky. You're looking at the totally right spot. 2 is the value we want. It's the sign of the 2 that's really tricky. It's actually -2. And so they're not trying to trick you. I know sometimes in mathematics it seems like that, right? But they actually wrote the function that we studied with a minus sign in it so that the H would tell you what was happening. Because when you guys graphed something like this, compared to the parent function that had its vertex at 0, 0, this graph actually moved in which direction? Yeah, go ahead. To the left, right? And so they're like, oh, how do we, that's confusing. So they wrote the equation as like x minus h, meaning h is really a -2 because it would take x minus -2 to make a +2 right here. So our h value is actually -2. It seems silly, but then it really matches up with the movement of the graph. That h being a -2 is a movement 2 units to the left if we're talking about shifting, okay? All right, what about our k value in this same equation? What did you guys identify as your k value? Yeah. Good. 0 because there's nothing there. And remember, we heard the nothing there thing before. And we said it was 1, but that's because the A value was multiplying the absolute value quantity, whereas the K value would be added on to the absolute value quantity, right? So before we go on to kind of summarizing what these things actually did, is everybody okay with looking at an equation and being able to identify what A, H, and K are? So if I give you one of these absolute value equations in this format here, are you going to be able to look and correctly say like, oh, the A value is this, the H is this, the K is this? It's like step 1. Right? Step 2 is to understand what each of those values are going to do to your graph. So you guys went through and you summarized, and I stole some people's summaries, so I'm going to go to those really quick. Actually, not that quick. Let's see. All right, so when we're looking at what the A value does, okay, there's actually a lot of different things and a lot of different ways that you guys can describe it. We're going to narrow down our language for how we describe transformations at the end of this unit going into the second unit. But so right now you see 1, A works like slope. Absolute value function does have lines on the side, so it does actually follow a consistent slope for each branch of it. So that's not a bad way to describe what the A value is doing, okay? But what we also want to notice is what's written in the other response up there, that it specifically then, because it does control slope, it either makes your V wider or narrower, okay? And we're not going to use those words all the time, but for right now, those words are totally appropriate. And then it also determines if our V is opening upward or downward. So A controls a lot of things, okay? It controls which way our V is going to open, and then it controls the slopes of those lines, which are making the V appear more wide or more narrow. All right, does that make sense to everybody? So if you have an adjustment that you want to make to your answer for that, you can. If you don't have an adjustment, if you're pleased with what you saw, then you're good. Okay. And you guys will have a couple minutes at the end too, so that you can go through and look. The next question was about the H value. So this response kind of summed it up. H is the X value on the graph, and I want to be a little more specific. The graph actually has a lot of X values, right? Which part of the graph particularly, James? The vertex. Good math terminology, okay? That place where your V turns around is your vertex, and that's where we're seeing that the H value corresponds to. That every time you graphed it, that X coordinate of the vertex was the same as the H value you would have pulled out of your equation. Which means what the H value is doing is it's taking that V that originally sat at 0, 0 with the parent, and it's moving it in the direction that X goes along our axes, so left and right, okay? So shifting left and right, all right? So H matches up with the X coordinate of your vertex and controls the shifting of the graph specifically in the directions left and right. And then finally K. So some responses up here, okay, that K represents how the graph moves along the y-axis and determines how far up or down the graph is, okay? So it determines where that vertex is moving up or down, which specifically corresponds to the y coordinate, okay? And so if you read the last response, if it's a negative value, then it's moving it down. If it's a positive value, then it's moving it up. So K and H are really similar, but H is working in the horizontal realm and K is kind of working in the vertical realm, changing the y coordinate and the vertical shifting, okay? If you need to make any corrections there, then go ahead and make them and then submit them again in your investigation. So this one's for the absolute value function, so you get the parent function there, and then next to it you get another function, and then it has a place for us to graph it and fill in all the characteristics about it, okay? So the first thing we want to do is we want to form the graph for our parent function. So what did that look like? You guys saw it on Desmos. Let's talk about the key characteristics. So like vertex, where was the vertex? Ethan? 0, 0. So let's fill in our vertex. Cute, right? Told you I was having problems. Okay, so let's fill in our vertex at 0, 0. Okay. And then what did we see as kind of the slopes, or that A value that was controlling how wide or how narrow the lines were? Is 1, okay? So in the positive direction from that vertex, our points were up 1 over 1, following like they would for a line with that slope. Okay. And then we have also the other branch of the absolute value graph that's using the opposite of that, so a -1 slope. So up 1, but to the left 1, okay? I'm not as good as you guys are at drawing straight lines, so forgive me. Okay. So we're going to go through the chart below, and you guys are going to see these same characteristics of everything we graph. And you're actually even going to see the same transformations that you saw, shifting and stretching things so they look wider and more narrow, okay? So we're going to go ahead and look at that chart. And the first few things we'll be able to just pull off the graph because they're pretty familiar to us. And then the next ones might require a little bit more work. So the first one just asks for the vertex. We've identified this a couple times. Someone knew. What's the vertex of this parent graph specifically? 0, 0. Good job. Okay. So 0, 0 is what we're looking for here. Okay. And then you guys know enough about intercepts here, and we'll talk more about how to find them later when they're not so clear. Who can give me the x-intercept for this graph? Sammy? The origin 0, 0, right? And somebody else, give me the y-intercept for this graph. Yeah, super. Good, 0, 0. So not super exciting. That's kind of what makes it the parent function. It hasn't been transformed. It's the most basic version of that graph, okay? What about domain? Who thinks they could tell us what the domain is for this function? Grace? Good. So when you guys look at this function, if you pick any x, let's say I pick an x value way out here, will that x have a corresponding y value for this function? Yes, so I can see from the graph, there's no holes in it, there's no place the graph stops. I can pick any point from left to right and there is a corresponding point, meaning every x value is contributing to a point on this graph and is part of the domain. So our domain is all real numbers. Who can tell us how we write it in interval notation? Good, negative infinity to positive infinity. My infinities look more and more like your guys' infinities every day, all right? All right, what about the range of our graph? Yeah, Jake.
All real numbers greater than or equal to 0.
Good. Okay, so he identified the point 0 that our graph is hitting and that we have everything above that but nothing below that. So none of our points will have like a negative y coordinate in them. So we can write that in inequality form as y is greater than or equal to 0. Or we can write that in interval form. Can anybody tell me what the interval form would look like? Luke?
Bracket 0.
Nice job, okay? And way to be specific about your brackets and parentheses. So notice we always go from minimum value to maximum value. When there is no maximum or no minimum, we're using that infinite notation. And that our bracket means we actually hit the point, like the equal to part of our inequality. And the parenthesis means we're not actually hitting that point, okay? Everybody okay with this information about this graph that's in front of you? A little more familiar. Okay, so now we're going to go to this increasing, decreasing intervals. And this is going to be a little bit more difficult to think about. I kind of think of it in two parts. If you guys want a different explanation after that, we can go with that. So I'm going to focus on the graph for a minute before we talk about the way that we're going to write it. And when I look at the graph, I just want to visually identify which parts of this graph fall into those categories, like what is increasing and what is decreasing. Okay? And the way that you do this is you're going to read your graph from left to right. So I'm specifically going to look like I'm reading a book from left to right and think about what would my behavior be if I was traveling along the line of the graph as I move from left to right. Okay? So if I'm moving from left to right and I start, I'm going like this at first, right? Because I'm moving from left to right. What kind of behavior was I just demonstrating? Increasing or decreasing values of behavior? Decreasing when we're looking at the y value, right? So this branch of the graph is actually considered a decreasing branch of the graph. So I'm going to go ahead and just write on there until I understand this a little better. And you might not have to do this in the future, but it's the first time we're seeing it. So I'm going to write it like this. Then I hit that point at the bottom. And the point at the bottom is kind of like neither here nor there. Like it could be part of the decreasing, it could be part of the increasing, it could be neither, it could just be chilling at the bottom, right? Not having to do anything yet. I don't really know, okay? But after that, as I continue moving from left to right, I start behaving like this. Okay? So how would we describe that behavior? Increasing. So I'm going to label this part of the graph as increasing. So I want to pause there and make sure everybody's okay with just that idea. Are you okay with understanding that you're going from left to right? Because if you look at it in another direction, it would totally change our responses, okay? So that's what's happening. Here's where we have to kind of disconnect how we're writing it with how we identified it. When we identified things as decreasing and increasing, we were looking at what was happening to the y's, right? Like the y's were going down, so it was decreasing. Then they were going up, so it was increasing. But when you guys write the interval, make a note for yourselves. We do not write it with y values. And this is one of the hardest things for students because you want to tell me like it went from 0 up to infinity. But you already told me that with the range, okay? This is about the behavior. And what you're really telling me is the domain values where the function is behaving that specific way. So you're saying, hey, Ms. Dahl, this thing behaves like an increasing thing for the x's from this number to this number, but then it switches and it starts behaving like a decreasing thing for the x's from this number to this number. Do you understand the difference between what you're telling me and what we just identified on the graph? So we looked up and down, but we're going to describe to somebody using the x values in the domain like, hey, during these x's, it's behaving like an increasing thing. But during these x's, it's behaving like a decreasing thing. That's the way you're interpreting it and explaining it to somebody. Okay, so when we look back up, the first thing it asks for is increasing interval. Yeah, okay. When I look at what I labeled as increasing, what x values does that correspond to? So where did the increasing interval start? 0 as an x value. Where did the increasing interval end? Never, so we use, you guys are using good language there, the infinite x value, right? So way out here, it just keeps going on forever and forever, and it continues that increasing behavior. So we call this graph increasing for the x values, okay, or on the interval from 0 to infinity. And whether you use a bracket or a parenthesis with that 0 is kind of up to you. It hasn't really been, there's been no purpose to like define you must say it doesn't touch it or you must say it does. So we kind of leave that open to your interpretation. You wouldn't be marked wrong either way. You would in the range, because the range means you reached 0 or you didn't, and so you would be telling me the wrong thing. But this is kind of left undefined in that aspect. Okay. All right, so now let's look at our decreasing. Where did our decreasing interval start? Negative infinity, right? There wasn't like a definite start to it. It was just like forever to the left, it's still like this, okay? So negative infinity. And then where did our decreasing interval end? 0. So when we describe that interval, we're describing to somebody that on the x values from negative infinity to 0, we are seeing the graph behave like a decreasing type of thing. Is that all right with everybody? Okay, it's kind of the most confusing thing that we have here. All right, yeah?
Use a bracket.
It doesn't matter. So you can use a parenthesis or a bracket for the 0 because it's kind of inconclusive whether they've included it or not. And I'm not leading you astray, I promise. Even when you take like your AP Calc test, they'll accept both. Okay? All right, the next thing talked about one-to-one. So here's what one-to-one is. First, to be one-to-one, you have to be a function. You have to meet that requirement. So we talked a little bit about this with our piecewise stuff. Okay, who can tell us what the rule is in order to be a function? Yeah. Okay, so not repeating x values. So really saying that if I use an x value, it should only have one y that pairs with it. It shouldn't come up again with another y paired with it, right? So every x should only produce one y value if it meets the requirements of being a function. You can graph stuff that's not functions. They just don't get to be called functions, like special title, right? So how do you guys test a graph normally to determine if something is a function? Vertical line test, okay? Because often you guys are doing this kind of thing, like here's an x. Does it hit any y more than once? So really your vertical line is just testing that there's only one y for that one x. Does this function pass that vertical line test? Yeah, so it is a function, right? To be one-to-one, you have to have that, but you also have to have that for every y, there is only one x value. Did you hear the difference in what I just said? So a function was for every x, there is only one y, but I am saying to be one-to-one, you have to have that as well as the requirement that for every y, there is only one x. How would you test that on this graph? Yeah, super. Yeah, you could actually use a horizontal line test because you want to identify a y value and be like, hey, across this whole y value, does that only match up with one x? Okay, so does this graph pass the horizontal line test? No. So we said this is a function, but do we get to call it a one-to-one function? No. Okay, so when we ask you if it's one-to-one, we're just looking for a yes or no answer here. And make any notes next to that if you have to, so that you remember what one-to-one is if this is the first time that you've heard it, right? And then below that, it talks about rate of change. How do you guys identify rate of change? What is that the same as? Slope, okay? And so this goes in both directions, so we kind of just let you guys right here that there is this constant rate of change of 1 for the branches, but it could be positive or it could be negative, depending on which branch we are looking at. And then what about our axis of symmetry? Who can identify where that is? Somebody new that hasn't talked. Yes. Good. So the y-axis is the axis of symmetry. And the axis of symmetry is a line, right? We're saying like this entire line, you fold the graph over on that line, you see the mirror image on the other side. So we want to label it like a line when we name it. Okay, that's going to be a big deal to us now. Like in Algebra 1, you guys might have just wrote a lot of numbers. But we need numbers to be numbers, points to be points, equations to be equations, because we're writing so much information, it could get very confusing if we don't know if that's horizontal or vertical, or if it's a point or a piece of a point or something like that. So we want to identify the y-axis, and we want to identify it as an equation of a line. What is the y-axis written as an equation of a line? How do we write that? Sam? Good, x equals 0. And then when you guys look at your graphs, we want to identify if there are minimum and maximum values. So there we are looking at y values, right, up and down. Did this graph have a minimum? Did it have a maximum? No. So when it doesn't have one, it's okay to just write that there isn't one, none, okay? Don't write infinity or anything like that. That's not actually a value you reach. You just say this thing is not present in this function by saying none. It doesn't have one. What was the minimum value? 0. And we're just listing a value, which generally for these, that means we are referring to the y value. So we can just list 0 here. We're not asking for the minimum point. And you will be asked different things in pre-calc. A minimum means like the minimum point. A minimum value means the y value of that point, okay? The language becomes really important. And then this function doesn't have asymptotes right now, so you can write none or not applicable to this type of function. Okay. All right, so what I want you guys to do for our last 7 minutes is see what you think you can do on the other side of this paper, okay? And when you come in on Monday, we're gonna check that and do a couple more examples and make sure you're totally set to apply what you learned to actual absolute value functions, okay? The only other thing I want you to know is that the weekly review is posted, the new one. So I don't print them out every week. That was just to get you started. So it's up on Canvas, weekly review 2. When is it due? Thursday.